Okay, our new topic is moments, one that should be quite familiar with you from year 10. So we've spoken about forces before, and we said some things forces can do is they can make objects speed up, they can make objects slow down, they can make objects change direction, but another thing a force can do is it can make an object rotate. And when a force is trying to make an object rotate, it's not just the size of the force that matters, it's also the distance that it is from the pivot. And those two things combine together to form a moment, and it's a moment that is really the turning effect of the force. It's a measure of the ability of the force to cause an object to accelerate in an angular way. And you would have learned in year 10 that moment equals force times distance. However, we have to learn this off slightly differently in year 11 for GCSE. So the moment of a force, it is force times distance, but a very particular distance. And it's this bit that people tend to leave out when they're asked to write down an equation in an exam. So it has to be the perpendicular distance from the pivot. What do we mean by that? Well, we would have done questions involving wheelbarrows. It is a wheelbarrow last year. And we would have had our distances, so this is a load, this would be the effort, and we'd have this distance here, and the distance from there to there would be the distance of the effort. They're perpendicular distances, okay, where the line of action of the force makes a right angle with the distance from the pivot. We never measured the forces like this, so there's where the effort's applied. We never measured the distance like that, because we can't use that in our equation, because that angle in there is not 90 degrees. Now, you can use trigonometry to work out different things if you're not given the distances, and you'll have to do that maybe in maths at GCSE and physics at A level, but every force you get should be perpendicular to a distance. Okay, so you shouldn't have to worry too much about that, but you do need to state this if you're stating what a moment is or how we calculate it. So we do still shorten that. The moment equals force times distance. Whatever the distance is measured in will govern what the moment is measured in. So quite often it's Newton meters if the distance is in meters, or Newton centimeters if the distance is in centimeters. You just have to make sure that they're consistent. Moments have a direction, and we look at a clock face to give us that direction. So the hands of the clock move by that, like that. So if it's going to make an object rotate in that direction, it's clockwise. The opposite direction then would be anti-clockwise. Okay, so let's look at an example. So here we're asked to find the moment of this 5 Newton force about the pivot P. We write out our equation, moment equals force times distance. We put in our values, 5 times 2. We calculate it, 10. But then we need to give a unit. Because this is in meters, it's going to be Newton meters. And if we look at that, it's spinning about here. So that downwards force on the right-hand side is making it turn clockwise. So always we need to think about the direction involved as well. Okay, that should all just be revision from year 10. Try the questions below yourself and mark them when I'm back in class.